Very much. Hi, everybody. So in our presentation today, we're just going to share some of the things that Ceragon has learned over the past several years dealing with many different kinds of utilities. And we'll focus on fixed wireless and where we see it used, how it's deployed, and what some of the trends are that are driving the need for fixed wireless in the utility market. Our agenda is we'll take a look at the typical utility network and where fixed wireless fits in the network, how utilities are deploying fixed wireless. There's many different ways to deploy fixed wireless, and we'll talk about the various methods that utilities are using. And there are trends that are impacting the use of fixed wireless that we'll talk about. And finally, the FCC has recently issued a ruling that could have an impact on a very popular frequency that is used by utilities. And we'll take a look at the ruling, what it means, and what you can expect for what comes next. So back in the good old days, maybe 10, 15 years ago, utilities had a few applications where they needed mission critical backbones, whether it was fiber or wireless. And that was teleprotection, usually, where they're protecting critical circuits coming from their very expensive substation equipment. And they needed very low latency connections to make sure that that equipment was operating properly and monitored properly. So teleprotection was always one very popular application for fixed wireless, as well as SCADA. SCADA is the control protocol that many devices use, and certainly that's widely used in utilities. And although not as latency sensitive as teleprotection, fixed wireless was always a popular way to backhaul SCADA devices throughout the utility network. And two-way radio traffic was always also one of the three major applications for fixed wireless in the utility market. But now we're seeing other applications come into play, and it's driving the need for even higher capacity fixed wireless, namely high definition video surveillance. We find a lot of utilities deploying this at different places in their network for a variety of different reasons. They're deployed at substations, which need to be highly secure facilities. You certainly don't want malicious behavior or bad actors infiltrating your substations, and so high definition video surveillance is used to monitor those facilities. You also see it used in the offices and other critical areas that the utility companies have, where they want to make sure that they know what's going on in the vicinity of their facility. Workforce mobility, we're seeing a rise in the adoption of private LTE in utility companies, and that as utility workers are using tablets and mobile devices to do their jobs. That all needs to be backhauled to typically to the monitoring center, and that's driving the demand for a higher capacity point-to-point wireless circuits. And then finally, AMI. In the good old days, the utility company would send meter readers out to every home and business to capture the readings of the electricity usage, and that's how the bills were done. Now, just about every utility we talk to is deploying automated meters. And these automated meters are at the home or at the business, and they're using usually very low capacity mobile type technology like UHF or LTE to broadcast their readings to a collection point. And those collection points typically will capture the traffic from hundreds of different endpoints. And it's those collection points that need to be collapsed or backhauled back into the main utility network. And we're seeing fixed wireless used in that application as well. So virtually we're touching every element of the network, from the power generation facility to the substations, to the end user via the AMI. We're also seeing where many utilities are incorporating solar panels or wind generation into their energy generation strategy, and we're seeing fixed wireless deployed out at the edge at those facilities as well. But even as we add more applications to the utility network, the basic requirements don't change. In the past, they were heavily dependent on TDM, T1s and OC3s for carrying their critical traffic. That's migrating to IP for a variety of different reasons. One is IP gives you more flexibility with the types of applications you can employ. It's easier to secure, and it gives you more control over the bandwidth and how it's used. Data demands are growing, as we just talked about, with mobile data and video surveillance. Private LTE, now that the CBRS spectrum has become available, it's an opportunity actually for utilities and their integrators to build their own private LTE networks, which need to be backhauled. Security is more important than ever. And that's not just, when we talk security, we're not just talking about encrypting the traffic, but we're talking about creating networks that are resilient and redundant. And I'll show you shortly how we do that with fixed wireless. And as has always been the case, the utility companies really don't like to rely on carriers for their mission critical links, whether it's a tier 1 carrier or tier 2 carriers. They really want to have control over their mission critical links. So they'll either bury their own fiber, or they'll use point-to-point microwave, which is in their control and easier for them to fix and maintain. And finally, utility companies are well aware of the requirement to make sure their networks are up and running 24/7. There's a lot of public and government incentive to keep them running. Those of you that live on the East Coast may be aware of the recent Colonial Pipeline incident, where hackers forced the shutdown of Colonial Pipeline's network, which disrupted the supply of gasoline to much of the East Coast. And fortunately, it looks like they're getting back online, but that had the potential, if it stretched for another few days, that had the potential to really disrupt gasoline supplies in the East Coast. So you can imagine, a utility company being the victim of an attack like that, where it disrupted their ability to distribute power for several days. That would be completely disastrous. So it's important that when they look at fixed wireless, that the fixed wireless solution have these redundancy, resiliency, and security features that they really need. So we'll take a look now at the various different ways that utilities are actually deploying fixed wireless solutions. And everything from, as we've seen, from the backbone to the middle mile, and then right out to the edge of the network, fixed wireless is in use. Today we'll talk primarily about licensed point-to-point microwave, but I do want to point out that at the very edge of the network, there's also a play for other types of fixed wireless, namely the CBRS spectrum provides an opportunity for integrators and utilities to use fixed wireless access devices that utilize the CBRS spectrum. And there's also widely used, unlicensed in the 5 gigahertz spectrum, point-to-point devices from a variety of different manufacturers that are used in less mission critical links. But today we'll be talking primarily about how they deploy licensed point-to-point fixed wireless. And really there's three styles for that. There's all indoor microwave, all outdoor microwave, and split mount. And we're going to go through each one of these, what they mean, and then there certainly are pros and cons to each of them. All indoor microwave historically is the way that utilities liked to deploy their systems. An all indoor microwave system means that all of the active components are located in a telecommunications hut or shelter, typically located at the bottom of the tower. The radio, the network unit that provides the brains of the radio and all of the network interfaces, and the customer's network switch are all located in the shelter, and typically waveguide is used to run from the radio up to the antenna. That defines an all indoor microwave system. Conversely, all outdoor means that the radio, the guts of the radio, the intelligence, if you will, of the radio and its network interfaces are all located out at the antenna up on the tower, typically direct mounted to that antenna. And then LMR, Cat5 or fiber runs from the radio down to the customer's network switch in the shelter. And there are pros and cons to each of these. I'm having trouble now with my advancing. Okay, so for some reason my slides aren't advancing. Okay, I'll have to use that. So there are pros and cons to each of these. On the all indoor side, obviously, it's easier to replace equipment if you need to, with nothing at the tower but the antenna. There's no tower climb if you needed to replace a radio or an indoor or a networking unit. You'll also have less equipment on the tower, which means less stress and loading on the tower. And all indoor equipment is best suited for supporting both TDM circuits and IP. And many utilities, although they're migrating to IP, still require some form of TDM support. Now, on the negative side for all indoor, it's expensive to install. You need crews that are specialized in installing and handling waveguide. That's typically a more expensive installation. The equipment is certainly more expensive. And because of the line losses with waveguide, you might, depending on the distance of the waveguide run and the distance of the link, you could need a bigger antenna in order to make the link work. On the all outdoor side, the obvious advantages are it's less expensive to install and maintain. And because you don't have the line losses from the waveguide, you may be able to use smaller antennas. So again, depending on your situation, if you have really restricted antenna heights that you can use on a tower because of the tower owner's availability or rules or cost of rental, all outdoor could be a good solution. But on the negative side, if a radio were to fail, the only way to get it down would be to climb the tower and replace it. And you can imagine, if that failure were to occur on a critical link at a very inopportune time, i.e. the middle of the night or the middle of a snowstorm, it might be impossible to climb the tower. And typically, all outdoor systems do not have a good TDM support. At most, you might find an all outdoor system that could support maybe a single T1. So again, depending on the type of network you need to support, that could be a disadvantage for all outdoor. The third type, and actually a style that I see growing in popularity with utilities, is the split mount architecture, where the radio is mounted on the tower next to the antenna, and you're running LMR or fiber down to the indoor unit, which has the brains of the radio and the major network interfaces. So you kind of get the best of both worlds. you get the low losses that come from having the radio up at the antenna, and you also get the protection capabilities of having an indoor unit down at the shelter, and you get the ability to support TDM as well as IP. Easier to maintain, a lot less expensive to procure and install. The disadvantage, obviously, is still your radio, which is located up at the antenna. However, most vendors with their split mount architecture also offer the ability to have a protected radio. So you'd actually have two radios located up at the tower. If one were to fail, the other would automatically take over, and that provides the protection and would help you mitigate, when you'd have to climb the tower to replace a failed unit. We really do see this one, because of the cost advantages, growing in popularity with our utility customers. So there are some major trends that are affecting how utilities look at fixed wireless now, and one of them is resiliency and survivability. Those are obviously still incredibly important considerations for building your backbone network. Not only do the utilities want to have their products secured by methods such as AAA authentication, where you're using more than just a username and a password, but they also want encryption typically, and in some extreme cases, FIPS, products that are FIPS rated for against tampering and other measures, security measures that are built into the FIPS standard. Because of the resiliency and survivability, they typically prefer licensed frequencies, which are a lot less likely to be interfered with. Private networks, whether it's a mobile private network, such as the kind you can build with your own CBRS spectrum, or a fixed network with licensed microwave, are preferred because they own all the components. They don't have to rely on a carrier to correct something if there's a failure. And then the other thing that's driving the resilience and survivability is the reach of the network. As we talked about, it's expanding to places where they didn't think they'd have to expand their network 10 years ago. They didn't think they'd have to be going to solar farms, which they may not own, or reaching their network out into a neighborhood to AMI collection points. But they need to do that. And at the same time, they need to keep those networks as resilient and survivable as the core networks that they've historically deployed. And of course, the TDM to IP migration is going to continue to be a major trend. In order to meet the federal guidelines, they have to migrate to all IP. IP does offer superior control for both bandwidth and quality of service through various techniques. That's easy to do. MPLS is a popular way to do that. And also, when you think about the way that the type of applications are growing, from video surveillance to mobile data, TDM could never support those kinds of applications. So another reason why we see the migration to IP. But even as those things are happening, they still have the need to support their legacy critical high priority traffic, such as teleprotection. And in those situations, most good vendors that provide licensed microwave in IP have very low latency products, so they certainly meet the latency requirements that are required by teleprotection applications. And then finally, and this is one that I see probably growing more than others, for those energy companies that are generating their own power, most of them are looking at green sources, solar farms, wind farms, and they're having to extend their network out to those locations. And typically, those locations don't have the kind of telecom footprint that the energy company is used to seeing. They may not be able to put a concrete shelter at the site to house their equipment. They might not be able to construct the kind of antenna structure that they could in their core network. So they're dealing with less footprint, antenna structures that might be less tolerant. And so they have to use smaller antennas, and also because they're not, each one of these locations isn't going to carry, have a tremendous amount of impact in terms of power supplied to the network, but yet they're still critical. They have to be careful of the costs that they incur when they're connecting these. So they're going to, this is where you'll most commonly see unlicensed or CBRS fixed wireless used, but also FCC licensed as well. So that kind of covers, the trends and how utilities are deploying fixed wireless. So now we'll talk about the decision that the FCC, or it's called a report and order, that the FCC issued last year around this time. This was really driven by the FCC's desire to improve the broadband, access to broadband for a greater portion of our country, rural America, and also the realization that Wi-Fi use is growing, and the applications that Wi-Fi is supporting are requiring more and more capacity. So the FCC made a decision to allow unlicensed devices to use the 6 gigahertz spectrum, which comes as kind of bad news to the utility industry, because point-to-point microwave, licensed microwave in the utility space relies quite heavily on the 6 gigahertz spectrum. So naturally, utilities are very, very concerned about the impact that unlicensed use in the spectrum could have on their existing 6 gigahertz links. Major sponsors of this movement to unlicensed use obviously would be folks like Apple and Cisco and chip maker Broadcom, Facebook, and others. They formed kind of a consortium to lobby the FCC heavily to open the spectrum up for unlicensed use. And we talked about how it's going to affect the Part 101 6 gigahertz users, the lower 6 gigahertz band and upper 6 gigahertz band, as well as broadcasters who use licensed 6 gigahertz. Well, the FCC's in response to the UTC and APCO and other industry organizations that represent the mission critical market, the FCC, as part of their order, is going to require that automated frequency coordination devices be used by anyone that's deploying unlicensed 6 gigahertz. And in theory, these devices would mean that before I can use my Wi-Fi 6 gigahertz access point, my AFC system would do a query of the FCC database and identify any 6 gigahertz frequencies that were licensed in my vicinity and move me to an unlicensed channel that wouldn't interfere with the licensed use. So that's the FCC's response for how they're going to mitigate interference. And in theory, that should work pretty well, and it already is a method that's employed in the CBRS world. In order for this to work, the data that's in the FCC's Universal License System, the ULS, has to be accurate. And because that's the system that the FCC is going to query before they assign an unlicensed frequency to the Wi-Fi access point that wants to access the network. And as I said, it's already a method that's in use with CBRS and white space systems, and it has worked pretty well in those situations. However, there are steps we recommend that utilities take to protect their 6 gigahertz systems. Many utilities are looking at moving off of 6 gigahertz and into frequencies like 11 gigahertz perhaps, which is also a licensed spectrum. But in practicality, there's many links that just won't give them the capacity and the reliability that they want outside of 6 gigahertz. So they're going to have to stay at 6 gigahertz. Hundreds and hundreds, if not thousands of links are going to have to stay at in the 6 gigahertz spectrum. And these are the steps we recommend that utilities take to mitigate opportunities for interference. One, survey your sites. Make sure that you've got accurate information on the tower GPS, the height that your antenna is actually placed at, and the gain. It could be that the information has changed. If you deployed this system, 15 years ago, perhaps it's been modified or upgraded in the interim. And it's very important to make sure that the FCC has the most recent data on the location, the height, and the gain of the antenna that you're using. So step 2 is once you've got that most up-to-date information, verify it in the FCC database. And I put a link in the slide here to the ULS database where you could search just by entering the call sign for the site. You could search their database and see exactly what the FCC has listed for that site. And then another important step to take is establish a baseline of your system's performance, the RSL, for example, and keep it up to date with regular monitoring. That way, if you start to see a degradation and you suspect it might be coming from interference, you've got some data to take back to the FCC and show them that your system's been degraded by the unlicensed use. And then finally, annual preventative maintenance. That's always a good idea, always has been a good idea. Antenna systems can corrode over time. The way they're wrapped to keep moisture out, that can change. Natural events can, like windstorm and hail and lightning, that can affect the integrity of the antenna system. So it's always a good idea to do preventative maintenance anyway. But if you have a 6 gigahertz system now more than ever, you want to make sure that the antenna system is still sealed and installed properly to further mitigate against any interference. Those are the kind of the major points we wanted to cover. I'm going to walk you through a little bit about Ceragon, who we are, what we're doing in the utility space right now. Just a quick snapshot of our company. We're publicly traded, operate in over 140 companies. All we do is licensed point-to-point microwave. That's our core competency. We create our own microwave chipsets, which gives us a unique position in the marketplace. We've been working with energy companies for many, many years. This is just a snapshot of some of the energy companies that use Ceragon systems now in North America. And we talked about the 3 different styles of licensed microwave. We support all 3. We have all outdoor systems. We have systems that are housed completely indoor, and we have split mount solutions. So whatever the application for the utility company, we have a solution that will meet their demands. Just to take a quick look at the flagship product that we typically recommend to utilities, whether it's an all indoor or whether it's a split mount solution. This chassis can be used to support the radios. It has redundant slots or redundant cards for the power supply, for the control card, and for the network interfaces. And again, this would be deployed in the shelter, and it could support radios that are also deployed indoors in the shelter, and it could support radios that are deployed outside up at the antenna, or a combination. It also comes in a 1 RU smaller footprint for sites that don't have as much density as, let's say, nodal sites would. The main benefits are no single point of failure. So as I mentioned, the redundant power supplies, the control cards, and the interfaces can all be made to be redundant. It supports both TDM and IP, OC3s as well as DS1s. We've got advanced features like layer 1 bonding. If we have many, many different directions coming into that one platform, we can bond them into one data stream going out onto the network. And in this one platform, we can support many different types of applications as well as different frequencies, licensed, unlicensed, the E-band, which operates at 80 gigahertz, as well as microwave band frequencies. And then, we talked about how resiliency and redundancy is very important to utilities, and they're trying to balance that with cost. All indoor systems are expensive to deploy. All indoor systems may not be feasible to deploy if you're out at the very edge of the network. And so the all outdoor systems that we sell can be made configured to be redundant. This is just one example. Our 50C platform can be configured as a hot standby. So if one radio were to fail, the other one would automatically kick in. It supports DC power, which utilities like, and it supports fiber coming down from the radio to the network, which utilities prefer because it's easier to protect fiber than Cat6 cable. So our all outdoor systems can be certainly made to be resilient and redundant. And what that really offers the utility is the ability to do TDM and IP in the same platform while you're supporting all of the major applications that you need to support, whether it's high capacity video surveillance that might require a gigabit or higher capacity using an E-band radio, teleprotection, which has to be very, very low latency, and might even still require a DS1 connection, as well as SCADA, which is could be done over IP. So you could have all three of these types of radios, all outdoor, all indoor, TDM and IP, all coming into the same tower site at the same node into one platform. So in addition to the utility market, obviously we're actively involved in public safety, oil and gas, transportation, the carrier market. Tier 1 carriers, particularly mobile carriers, are big consumers of licensed point-to-point microwave. So just be aware we operate in all those verticals as well. We also offer a complete suite of turnkey services, whether it's planning the network, deploying the network, or operating the network. We've got the expertise to help you do that. We're in a very good position financially with no debt, profitable, and leadership position, I should say, in the worldwide microwave market. We make our own chipsets, which gives us technology advantages, and we've got a lot of experience deploying carrier-grade solutions. That's really it. At this point, if anyone has any questions, we'll open up the floor to that.